Hello, my name is Vivek. I'm here to explain my project classification of Reuters multi-label text articles using machine learning techniques. Remarkable endeavors that has the potential to reshape landscape of information retrieval and decision-making process. As listed, you can see today's agenda that are introduction, dataset, pre-processing, machine learning algorithms, result, future work, and conclusion. And here comes introduction. There is a huge amount of data that is generated daily and is readily available. A very large segment of this data is textual data. Right? This makes it extremely difficult to comprehend this data and try to understand correlation between this data. This is why it is extremely important to be able to classify and categorize this data together. This is where text classifications comes into play. Text classification is the process of categorizing text documents into predefined categories or classes based on their content. Text classifications offers a way to analyze and extract insights from the vast amount of textual information. Text classification also provides an automated way of organizing and understanding the vast amount of textual data that is generated every day, making it an essential tool for data-driven decisions making in various data sets. We use the Reuters 21578 for the purpose of this project. The Reuters 21578 benchmark corpus is widely used collection of newswire articles used in natural language processing research. The optimal version of Reuters 21578 corpus contains 21,578 documents, each of which is assigned one or more topic codes from predefined set of categories. The categories cover a wide range of topics, including business, finance, politics, and sports. In addition to the topics codes, each document in the corpus also includes a headline, a date, and the full text of the article. Pre-processing. Original data has lot of noise and unwanted information. Thus, it becomes very critical to extract only the relevant data and for meaningful classifications. This requires a lot of pre-processing. Let us understand some concepts before we look into the step involved. One of them is tokenization. It is very common aspect of natural language processing task where the entire text is essentially broken down into many smaller chunks, which can be letters, words, phrases, or some even sentences in some cases. Second one is stemming. Stemming is process of obtaining, extracting just the root of any given word. For example, studies becomes study, studying becomes study, and studied becomes study. Lemmatization. Lemmatization is the process of obtaining the lemma or the original dictionary form of any given word. For example, for studies, studying or studied. The lemma for this word is study. Next, stop word removal. There are a lot of filler words in a textual content. Words like and the, etc., which do not really add a lot of meaning to the information. Stop word removal is the process of removing these words from the data to retrieval the words that actually are relevant and give meaning to the contents of the data. For the purpose of the project, I first removed all the end spaces and then removed all the special characters from it. After doing this, I removed all the stop words from the text. The next step is to perform lemmatization to obtain the original dictionary form of each of the words in the remaining text. And finally, I did the tokenization of the data. Feature extraction. The concept of backup words is very prevalent in the natural language processing based applications. This is nothing but the generation of an independent vocabulary for the purpose of model training. This means that each article is represented as a set of words represented mathematically as a vector. The vector length remains constant for all the articles in the dataset, where we use the TF IDF concept for implementing. What is TF-IDF? It is term frequency inverse document frequency. It is just a basic natural language processing technique. To obtain the vector or numeric representation of the corpus of the textual data, the following equation is being used. Wij is the TF-IDF score obtained from each term I in the document J. TF I of J is the term frequency for I in J, and IDF of I, on the other hand, is its IDF score. Machine learning algorithms. I used the following machine learning algorithms for this project, that are KNN, decision trees, bagging, random forest, boosting, multinomial naive and support vector classification. KNN. KNN stands for K nearest neighbors, machine learning algorithm used for classification and regression tasks. The KNN algorithms works by finding the K nearest data point to the new input data point based on some distance matrix. Most commonly used is Euclidean distance. Other distance measurement possibilities are Manhattan distance, Levantine distance, etc. KNN predicts the label of a new data point based on the labels of its K nearest neighbor in the training data. Decision trees, a popular machine learning language algorithm used for both classification and regression tasks. The algorithms create a tree-like structure that represents a series of decisions and their potential consequences. The decision tree algorithm recursively partitions the data into smaller subsets based on the value of the features, creating nodes and branches until it reaches stopping citation, such as a maximum tree depth or a minimum number of instances in the node. The decision tree can then be used to predict the target variable for a new instance by traversing the tree based on the value of their feet. Bagging stands for bootstrap aggression. It is a machine learning technique that involves creating multiple nodes using the same algorithm but trained on different subsets of a training data. The process involves randomly selecting a subset of the training data to create a new training set with the replacement of it. This process is repeated multiple times and a new model is trained on each subset of data. The final prediction is then made by aggregating the prediction of the models, either by taking the average or majority voting. Random forest. Random forests are an assemble learning method for classification, regression, and other tasks that operate by constructing a multitude of decision tree at training time and outputting the class, that is mode of classes or mean prediction of the individual trees. At prediction time, the random forest combines the prediction of individual decision tree to produce a single output. In classification tasks, the random forest output the class that is the mode of the classes predicted by the individual trees. Boosting. Boosting is the machine learning technique that combines multiple or weak simple models to create a strong or more accurate model. The basic idea behind boosting is to train a series of weak models such as decision trees or neural networks, each of which focuses on different aspects of the data. The final prediction is weighted combination of the prediction from all the models. It is particularly effective when the individual weak models are simple and prone to the making different types of errors, so that their combination can lead to more robust and accurate overall model. Naive Bayes classifier. Naive Bayes is a classification algorithm that is based on Bayes' theorem. It is a simple probabilistic algorithm that makes prediction based on the probabilities of a certain event occurring given some evidence. The algorithm works by first calculating the prior probabilities of each class, which is the probability of each occurring data in the dataset. Then for each new instance, the algorithm calculates the probability of the instance belonging to each class given in the features using Bayes' theorem. Finally, the algorithm selects the class with the highest probability of the prediction class for this instance. Support vector classifier. It is a supervised learning algorithm. The SVC algorithm works for finding a hyperplane in the high dimensional space that separates the different classes in training data. The hyperplane is chosen such that it maximizes the margin, which is the distance between hyperplane and the closest point from each class. In class where the data is not linearly separatable, the SVC can use a kernel function to transform the data into high dimensional space, where a hyperplane can be found to separate the class. The SVC algorithm is popular choice for classification tasks due to its ability to handle complex data and high dimensional feature spaces. I trained all these models of the Reuters dataset to generate the classification. Based on the model performance, I evaluate and compare the accuracies of each of these models against each other to see which has the highest performance. I use the following metrics to judge the individual performance of each model: accuracy, precision, recall, and F1 score. Micro F1 score is metrics calculated as the Hamoic mean of the precision is recalled, and where both the precision and recall are calculated using true positive, false positive, and negative values for the entire dataset rather than separately for each classes. As I told in the before slide, comparison was done between this. The support vector classifier model trained using the squad hinge loss gives the best performance among all the classification models used, resulting in accuracy about 87%. This was the work which was done in my project. The future work which can be implemented is we can improve the classification by using word embedding insert of a backword concept. This words embedding can be the supplier for training to advanced neural network models like RNN, CNN, LSTM, and etc. For the purpose of this project, I experimented with a combination of word2vec and the LSTM for classification. However, the training of LSTM failed multiple times due to computational limitation. Let us look at this concept and understand why such a pipeline can be result into much higher accuracy. Word2vec, a neutral network-based approach to generate word embedding. CBOW and skipgram. For CBOW, the neural network is set up in a way that it uses the context of each word as input and aims at predicting the word based on context. CBOW is trained to predict a single word from fixed window of size of a context word. Skipgram does the opposite and tries to predict several context words from a single input. LSTM. LSTM stands for long short term memory. It is a type of recurrent neural network architecture that is particularly well suited to tasks involving sequential data. LSTM addresses the problem of vanishing gradients and retain memory from the previous steps. By allowing the network to selectively retrain or discard information, the LSTM networks are able to effectively capture long term dependencies in sequential data, making them a powerful tool for a wide range of application in natural language processing, speech recognition, and other domains. Finally, the conclusion. I use Reuters dataset to multi-level text classifications. I use TF-IDF for feature extraction. I have compressed the performance of KNN, decision tree, bagging, boosting, SVC, multinomial name pies. We can see that support vector classification using a linear kernel gives the highest classification accuracy of 80%, 87%. A continuous of this work, it will be interesting to compare the results of word2vec plus LSTM and also word2vec plus logistic regression for multi-label text classification, which are also expected to result in higher accuracy. Thank you.